Hi, Advent of Code is starting. Let's try it. First problem is public. I think when you solve it, you get harder version, so there are actually two problems to solve. I will do it in C++. Okay, this might be beginning of the problem statement. Locations are listed by location ID. We split into two groups, each searching the office and trying to create their own complete list. Two lists side by side are not very similar. 3 versus 4, 4 versus 3. Pair up smallest with smallest and so on. Find the sum of distances. Can there be ties? What if there is 3 and 3? Smallest number in the left list is 1. Smallest number in the right list is 3. Oh, they are not talking about the distance of indices. Okay, I was confused. I guess distance suggests that it's the difference of index. Like this thing versus that thing, for me it would be distance of 1 because of the positions. It's just the difference. Instead of distance, they should have used the word difference. Okay, so we pair up number 1 versus number 3, and that's the difference of value 2, and so on. And we need to sum this up. Get your puzzle input. So we will read until end of file, I'm guessing. This is in 1000 numbers. Just create two vectors 1000 times, read the two numbers, a pushback x sort, and get the sum at corresponding position. Sum plus equal the difference, absolute value of the difference. It's not a good habit to leave a constant like that, so let's make a const 1000 obviously, and I don't know if long is needed, but just in case, and print the sum. When the problems are more difficult and actually we need to figure out some algorithm, I will explain more. That's the right answer. Continue to part 2. A lot of location IDs appear in both lists. How often each number from the left list appears in the right list? Similarity score, by adding up each number in the left list after multiplying it by the number of times that number appears in the right list. So it's a completely new problem, right? 0, 1, how should I call it? Part 2 .cpp. Is the input the same? No, yes, the input is the same. So we can do this. If you want the frequency in the other list, then the easiest way to do it is a map, dictionary, hash map. It's actually not the fastest solution. Maps do have big constant factor, but with such small data, we don't really care about it. So this is how you measure how many times things appear in the second list. And then for every object in the first line, you add what? The product of, you add number in the left list after multiplying it by the number of times it appears in the right list. Sum plus equal, just in case that is long, frequency of this number. Frequency measures how many times this element appears in the other list. In C++, by the way, it's better to iterate elements like this. If you don't need the index I, then it's only nicer not to use it. Let's see. 0, 1, part 2 on the input, this thing, submit. Right answer. Okay. Understanding the statement was longer than actually solving the problem, but I would argue that's because of the word distance, which suggested the difference of positions. It made me think, if there are multiple equal values, then which one should we look at? Well, okay. I will publish the solution maybe every day once the leaderboard is full. This is what the rules say. So the top 100 people appear in the leaderboard. Once the leaderboard is full, then it's fair to post the solution on YouTube. So yeah, see you tomorrow for day 2 and for the other problem. Maybe it will be more challenging in terms of thinking about the solution, so then you will get more explanation, maybe some drawings and so on. See you tomorrow. Bye.